A unity feedback control system has G of S equal to 15 upon S plus 1, S plus 3, and S plus 6. Draw the Bode plot. Let us include hence find gain margin and phase margin. So to draw the Bode plot, the given transfer function must be in time constant form, but it is in pole zero form. 15 upon S plus 1, S plus 3, and S plus 6. It is in pole zero form. To convert this into time constant form, we have to take 3 and 6 out. So S plus 1 multiplied by 1 by 3 S plus 1, 1 by 6 S plus 1, and 3 and 6 taken outside. That's why 15 divided by 18. That is equal to 0.83 upon S plus 1, 1 by 3 S plus 1, and 1 by 6 S plus 1. The corner frequencies are, now it is in time constant form. Now it is in time constant form. Corner frequencies are 1, 3, 6. Now we can prepare the table to draw the Bode plot. The table consists of first column is factor, second column corner frequency, third column slope contributed by each factor, slope by factor, each factor, and net slope, and then coordinates to draw the Bode plot. We are going to draw this on semi-log sheet. Y-axis is in dB and x-axis in log omega. The scale is in logarithmic scale. That's why we won't take log, but omega will be directly written on logarithmic scale. Graph sheet. Factors are 0.83, 1 by first corner frequency is 1, therefore 1 by S plus 1. Second corner frequency is 1 by 3, 1 by 3 S plus 1 second factor. Third factor is 1 by 6 S plus 1. Corner frequency, no corner frequency for constant. Corner frequency is 1, corner frequency is 3, corner frequency is 6. That's all. Here, slope, no slope by, it is a horizontal line, constant. For that, if you take, no, therefore net slope is 0. Here for this, if you take 20 log 0.83, that is equal to minus 1.6. Magnitude is minus 1.6 dB. So the coordinates, the lowest corner frequency is 1, therefore we will start with 0.1. Therefore 0.1 comma minus 1.6. So this is the Bode plot. We start with the 0.1, 1, 2, 10, 100, 1000, etc. This is in log omega. This is in dB. So here 0.1 magnitude is minus 1.6. Here minus 1.6 starts here. Okay. Then second, here the slope by the factor is minus 20 dB because the first order factor in the denominator. Slope contributed by again first order factor in the denominator, again minus 20, again minus 20. Therefore, net slope is here minus 20, minus 40, minus 60. Here up to the corner frequency 1, up to corner frequency 1, the slope is no change. After the corner frequency, slope will be changed to minus 20. That is the meaning. This is after corner frequency. After corner frequency. Corner frequency is 1. Therefore, up to 1, it is minus 1.6 only. After that, therefore, at 1 also, the magnitude is minus 1.6. So, up to 1, it is 1.6 only. After that, at 3, up to 3, 20 dB, it decreases up to 3, it decreases at the rate of minus 20 dB per decade. Minus 20 dB per decade. Therefore, here, the slope up to 3, it decreases at the rate of minus 20 dB. So, at 3, we have to find. Now, we have to find the coordinate for this 3. X coordinate is 3. We have to find the y coordinate. For that, let us use the equation for straight line. That is y2 minus y1 equal to slope. Therefore, we can write log x2 minus log x1. This can be written as y2 equal to slope multiplied by log x2 or omega 2 by omega 1 plus y1. So by using this formula, we can find the coordinate. So now we have to find the coordinate for 3. 3 means about here, it is 3 is here. So here we have to find the coordinate. For that, y2 is unknown. Y1 is minus 1.6. Slope is up to 3, the slope is 20. Up to 3, the slope is 20. After 3, slope becomes 40. Therefore, this is equal to minus 20 multiplied by log 3 by 1. Log omega 2 is 3, omega 1 is 1, plus minus y1, that is 1.6. That is equal to minus 9.5. That is equal to minus 9.5. Therefore, the coordinate is minus 9.5. Now, we have to find the coordinate for this 6. Omega 2 is 6. Omega 2 equal to 6. Omega 1 equal to 3. Y1 equal to minus 9.5. Y2 we have to find. Slope is minus 40 because up to 6 slope is 40. Therefore, we have to write y2 equal to slope is minus 40 log omega 2, that is 6 by 3, that is equal to minus 12. So the coordinates are minus 12 here. Next, we have to find another 1 decade away. So the corner frequency is 6. After corner frequencies, to extend the plot, we can take 60, 1 decade away. 1 decade means what is the net slope? 60. Therefore, 12 minus 60 equal to minus 82. Coordinate is 60, minus 82. That's all. So now we can plot at 3, what is the slope? Minus 9.5. So it turns this way. At 3, it is decreased to minus 9.5. At 6, it is about minus 12. And about 60, it is 82. 82. It goes like this. This is magnitude plot. Magnitude plot. That is dB versus log omega. Phase plot now we have to draw. The phase plot is, let us find the angle for these corner frequencies. If you find the and point 1, these coordinates, For these x coordinates, let us find the angle. Angle equal to what? We have to write expression for g of j omega equal to 0.83 upon j omega plus 1 by 3 j omega plus 1 by 6 j omega plus 1. If you find the angle for this angle of g of j omega equal to minus tan inverse of omega minus tan inverse of omega by 3 minus tan inverse of omega by 6. So we have to draw a table of entries. Table of entries and angle. This is omega, angle of g of j omega. 0, 1, 3, 6, and infinity. When it is 0.1, we missed 0.1. Before that, 0. 0 point, when it is 0.1, the angle is minus 8.6. 8.6. When 1 minus 67.5. When it is 3, 107. 107. And when it is 6, it is 120. And when it is 60, it is 133. Minus all negative values. When it is 0, what happens? If you substitute 0, you will get a degree, angle is 0. If you put infinity, tan inverse of infinity is 90. Therefore, you will get 270. 2 minus 270. Therefore, the minimum angle is 0. The maximum is 270. Therefore, the plot will be looking like this. You plot from 0 to minus 270. If you plot, the plot will be looking like this. This is 270. This is 0. So, yeah. Now, in addition to that, we are going to find the gain margin and phase margin. It is not asked in the question, but let us include it. To find the gain margin, we have to draw a line at 180 degree. Draw a horizontal line. It cuts here at 180, minus 180. Draw a vertical line. It cuts here. Find the magnitude. Magnitude is minus 24.5 dB. Therefore, gain margin equal to minus of minus 24.5 equal to 24.5. Gain margin. Phase margin, how to find? To find phase margin, where it crosses 0, we have to see. It starts at minus 1.6, end at minus infinity. Never crosses 0. Therefore, phase margin equal to infinity. Never crosses 0. That's why phase margin is infinity. Now let us verify the Bode plot by simulation. What is the transfer function? 15 upon s plus 1, s plus 3, and s plus 6. If you expand this, what you will get is 15 upon s cube plus 10s square plus 27s plus 18. So numerator is 15 alone. Therefore, numerator equal to 15. Denominator equal to the coefficients of s cube is 1. Coefficient of s square is 10. Coefficient of s is 27 and the constant term is 18. That's all. So now we have to convert this into transfer function. Transfer function, numerator, comma, denominator. So the given transfer function is 15 upon s cube plus 10s square plus 27s plus 18. For this, we have to draw the Bode plot. So Bode transfer function. Transfer function is stored in ANS, therefore ANS. So we got the Bode plot. Bode. This is the Bode diagram. So we can verify gain margin, phase margin by calling one more function. That is called the margin. Gain margin, phase margin will be given margin ANS. We call this, if you see the figure, gain margin is 24.5. We also got the same. Phase margin is infinity. So the phase crossover frequency is 5.2. At 5.2, it crosses 180 degree. Draw a vertical line, and it crosses 180 degree at 5.2 radians per second. Draw a vertical line. So draw a horizontal line at 180. It cuts at 5.2 radians per second. Draw a vertical line at this point. It meets the magnitude plot here. Draw a horizontal line. That is equal to minus 24.5. So minus of minus 24.5 equal to 24.5. Therefore, gain margin is 24.5. It's verified.